a beam of monochromatic blue light. Monochromatic blue light. Monochromatic means wavelength of single wavelength, light of single wavelength, of wavelength 420 nanometer in air. Its wavelength is 420 nanometer in air. So we can say lambda in air is given as 420 nanometer. Travels in water, it enters water. What is the wavelength in water? What is wavelength in water? The straight relation is simple. Lambda in any medium is nothing but lambda in air divided by refractive index of that medium. So the basic equation is like this. Lambda, wavelength in any medium, lambda in a given medium is equal to lambda in vacuum or air, because that is almost the same. Vacuum divided by refractive index of the medium. That is the relation. Okay. So here lambda in water is required, lambda in air is given as 420 divided by what is the refractive index of water given? It's given by 4 divided by 3. So this gives you 420 into 3 by 4. And you can see 4 will go in 120, how many times? 105 times into 3. So your answer must be 315 unit is same nanometer. So what you understand is this: when a light ray go from a rarer medium like air into a denser medium, we know its speed decreases. Speed decreases and wavelength also decreases. So frequency is the ratio of speed, let us say speed is V divided by wavelength. Frequency remains constant, speed decreases, wavelength also decreases, proportional. So the same relation holds good for wavelength also. Okay. So the answer is 315 nanometer. Next one, this is again from NCERT textbook. Okay. What is given? Refraction of light from air to glass and from air to water are shown in figure 1 and 2. The value of angle theta in the case of refraction as shown in figure 3 will be. So here air and glass, light is going from air to glass. In air, angle of incidence is 60 degree, and in glass the refraction angle is 35 degree. Similarly, when it goes from air to water, angles are 60 and 41. Now this is going from water to glass. What is the angle? Theta. The angle here is 41. Directly you can apply Snell's rule in all the 3 cases. See, you don't need Snell's rule actually here. You can by observation we can say answer must be 35 degree. But let us work out. In case number 1, I can apply Snell's rule. This is going from air at 60 degree. So NA sin 60 is equal to, this is glass. So I can write N glass sin 35. First diagram. For the second diagram, I can write it's going from air to water. So I can write NA sin 60 is equal to NA sin 60 equal to, the second medium is water, N water, and the angle is given there as 41 degree, sin 41. Snell's rule. For the third diagram, it is N water, it's going from water at 41 degree, N water sin 41 should be equal to, this is glass, N glass sin, angle is marked as theta. So we got 3 equations. Now can you compare? Yeah, very good. See, NA sin 60 equal to NG sin 35, NW sin 41. right? So NW sine 41 is actually equal to N glass sine 35. So from equation 1 and 2, I can say that this NW sine 41 is equal to N glass sine 35 from first and 2. This is equal to N glass sine theta, which implies that theta is equal to 35 degree. Pretty easy. It tells you about Snell's rule. And see, everywhere you have to observe that whichever is denser, angle will be smaller. Air and glass, glass is denser, angle is 35. Here, air and water, water is denser, angle is less. Here again you can say this is water and glass, and water and glass is denser than water, angle theta must be less than 41. Okay. One more from refraction, direct one. A ray of light passes from vacuum into a medium of refractive index mu. The angle of incidence is found to be twice the angle of refraction, then the angle of incidence is. See, here light is going from vacuum to another medium and the refractive index is given as mu. See, refractive index sometimes will be taken as n, sometimes it is taken as mu. Okay. We need to find out angle of incidence, but one condition is given. What is it? Angle of incidence I, angle of incidence I is equal to twice the angle of refraction. This condition is given. What is the angle of incidence? We need to find out I. How much is I? This should be calculated. Okay. Let us draw a diagram. This is vacuum. And this is the other medium. There is another medium. Refractive index is given as mu. This is coming from vacuum, and vacuum is the rarest of all. Any other medium must be denser than vacuum. So instead of going straight, this will bend like this. This angle is called angle of incidence, and that is twice the angle of refraction. No doubt. It is twice the angle of refraction. This is the normal, this is the refracted ray, this angle is R. Okay. Now you can apply Snell's rule. See, vacuum has got a refractive index 1. This has got a refractive index mu. So we can write like this: sin I by sin R should be equal to refractive index of the denser medium mu with respect to vacuum. But if you know I equal to 2R, so I will write here sin 2R divided by sin R equal to mu. What is sin 2 theta? It is 2 sin theta cos theta. So this can be written as 2 sin R cos R divided by sin R equal to mu. Immediately sin R and sin R cancel. So what do you get? We get 2 cos mu, 2 cos R is equal to mu. So what is cos R? It is equal to mu divided by 2. So what is R? R is cos inverse mu by 2. So we got R, but we want I, but I is nothing but 2R. Therefore I is equal to 2R, which is equal to 2 cos inverse mu divided by 2. And where is that option? 2 cos inverse mu by 2 is this option. We use the trigonometric relation identity sin 2 theta equal to 2 sin theta cos theta, and directly we use the Snell's rule. Have you seen a kingfisher catching fish? A kingfisher waits in a tree and as soon as he locates a fish, suddenly come like a bullet, catches it, and within no time it catches the fish and go. But you know, the life of kingfisher is really difficult. Why? Because of all these problems of refraction. A bird in air looks at a fish vertically below it. There is a bird in air looking at a fish inside water which is vertically below that. H1 is the height of the bird above the surface of water, and H2 is the depth of the fish below the surface of water. So, bird is at a height H1 from the water surface, and the fish is at a depth H2 below. The refractive index of water with respect to air is given as mu. Then the distance of the fish as observed by the bird. So, bird will see this distance. Okay. For the bird, how much is that distance? This is related to the concept of apparent depth, because when you watch inside water, the depth will be always shorter than the actual value, and we studied that one. We studied it as actual depth and apparent depth. I hope you remember. We studied that the apparent depth dA is equal to the real depth divided by refractive index. We studied that. Apparent depth is equal to real depth divided by refractive. We studied that. We just have to apply this. Okay. Now let us say this is the water surface and this is the bird. Bird. How to draw a bird? This is my bird. This bird is flying, and the bird is at the height H1 from the surface, and the fish is here. And how to draw a fish? This would look like a fish. This is my fish. The fish is here at a depth H2. Now the bird is watching. Bird is the observer. An observer is in air. So when you are in the same medium, the distances in the same medium will appear as H1 itself. So this distance will be seen as H1 itself, H1. But this one will appear as an apparent one, and that is calculated like a actual depth divided by refractive index. So the distance from the bird to the fish as seen by the bird is H1 plus H2 by mu. This is seen as a real depth, real length, but this is seen as a apparent. So this becomes shorter. Okay, H1 plus H2 by mu. And I am giving you some food for your brain. What will be the distance from the fish to the bird as seen by the fish? As seen by the fish. You have to work out in detail about apparent depth, then you will understand. Okay. This is a question from NCERT, and this has come 2 times in your board examination. Once as a derivation, another time as a numerical question. It's about apparent depth. What is given? There is a water tank. There is a water tank filled up to 12.5 centimeter, and there is a needle lying at the bottom of the tank. So there is a water tank. There is water up to 12.5 centimeter. There is a needle lying at the bottom. A microscope focuses onto the needle, and the depth is measured as 9.4, because when the microscope focuses on it, the needle will not be here, the needle will be appearing somewhere here, and the microscope is measuring this distance as 9.5. 9.4. It is measured as 9.4. So actual depth is 12.5, apparent depth is 9.4. So refractive index is equal to actual depth 12.5 divided by apparent depth 9.4, and this will come around 1.33. Please verify that, 1.33. Now if water is replaced by a liquid of refractive index 1.63 up to the same height, suppose you replace this water by another liquid, then what will happen? The apparent depth will change. Then the apparent depth d apparent will be given by 12.5 divided by, that is actual depth, divided by 1.63. Okay, this will be approximately 7.63 centimeter. Now see, initially it was seen as 9.4. Now this is seen as 7.63. Okay, so the microscope must be adjusted for this distance, and by what distance would the microscope have to be moved to focus on the needle again? That means initially microscope was focused to this level, but the needle now appears at a 7.63. That means shorter than this. This is 7.63. So the microscope should be adjusted by a distance of 9.4 minus 7.63. That is the answer. Next one is also about apparent depth. A small pin fixed on tabletop is viewed from above from a distance of 50 centimeter. By what distance would the pin appear to be raised if it is viewed from the same point through a 15 centimeter thick glass slab held parallel to the table? Okay, so there is a table, there is a small pin fixed on the table. This is viewed from a distance of 50 centimeter. By what distance would the pin appear to be raised if it is viewed from the same point? That means you are watching from this same point. This is at a distance of 50 centimeter. But you place a glass slab here. You place a glass slab whose thickness is 15 centimeter. Then what happens is that when you watch from this one, the pin will not appear at the same point, at the exact location, but this will appear raised, say here. This is what we call as shift. And we have equation for the shift. What is the equation for the shift? It is equal to thickness of the slab, the thickness T, into 1 minus 1 by n. And this is equal to thickness is that of the slab 15 into 1 minus, what is the refractive index? Refractive index is 1.5. This can also be written as 3 by 2, and reciprocal of that one, 1 by 3 by 2. 1 by 3 by 2 is 2 by 3. So this is actually 15 times 1 minus 2 by 3 is 1 by 3. So this gives you an easy answer of 5 centimeter. So when you watch it through the glass slab, the pin will appear 5 centimeter raised from its real position. Shift of something. Equation T into 1 minus 1 by n, where n is the refractive index of this slab with respect to the surrounding medium. Next one is from total internal reflection. This question may appear difficult, but there is a very easy shortcut to do this without knowing any optics. Okay. What is asked? Light travels in two media A and B with speed 1.8 into 10 to the power 8 and 2.4 into 10 to the power 8 meter per second respectively. Then the critical angle between them. Critical angle. Okay. Critical angle is given by the equation. Critical angle is given by the equation sin C equal to 1 by n. But when I taught you critical angle, I told you that you have to study this. It is the critical angle is sin C equal to 1 by n denser with rarer. So this gives you sin C equal to, reciprocal of this one is n rarer denser. And by definition we know this is nothing but n rarer divided by n denser. Okay, so sin C equal to n rarer divided by n denser. So that is where we arrived. Now let us consider the definition of refractive index. Refractive index is always C divided by V. C by V. So refractive index of rarer medium is equal to C by velocity in the rarer medium. Similarly, ND is equal to C by VD. So when I substitute that here, NR is C by VR. So this is C by VR divided by C by V denser. So this C and C cancel. I will finally get V denser by V rarer. So I am writing sin C in terms of the given speed. So what is the denser medium here? Which is denser medium here? Denser is the medium where speed is less. So here speed is less in the medium A. So that is 1.8 into 10 to the power 8 divided by this is 2.4 into 10 to the power 8. So 10 to the power 8, 10 to the power 8 cancel. What do you get? 1.8 by 24 is like 18 by 24. 18 by 24. You can divide it by 6. So you will get 3 here and 4 here. 3 by 4. So what is the critical angle? That's what they asked. So sin C is equal to 3 by 4. Sin C equal to 3 by 4. So C must be sin inverse 3 by 4. Which option? Option D. Sin inverse 3 by 4. I told you there is an easy shortcut because sin C should be a ratio of velocity. Sin C should be ratio of velocity. Understand that. And can sin C greater than 1? No, sin C should be less than or equal to 1. So out of the two given speed, if you want sin C in such questions, what to do? Sin C equal to velocity lower divided by velocity higher, because the other possibility is not possible at all. Sin C should be less than or equal to 1, so lower speed by higher speed. So immediately 1.8 by 2.4 is your answer. This is an out and out question because this is an object lying along the principal axis, because most of our question objects are perpendicular to the principal axis. So a rod of length 10 centimeter lies along the principal axis of a concave mirror of focal length 10 centimeter in such a way that its end closer to the pole is 20 centimeter away from the mirror. Let us do a diagram, ray diagram. Let us throw some light into the picture. Okay, it's a concave mirror. So let us do the concave mirror here. This is the principal axis. This is the pole. They have mentioned about pole. The concave mirror has got a focal length of 10 centimeter. So this must be 10 centimeter. This is where you have the center of curvature at 20 centimeter. The rod of length 10 centimeter is lying along the principal. It's lying like this, such that the end closer to the pole is 20 centimeter away from the pole. So you can see that the rod is lying, one end is close to the pole, the other end is away from the pole. The closer end is at 20 centimeter. Aha, that's great. The closer it is at 20 centimeter means, it means what? This is lying like this. Okay, and the rod has got a length of 10 centimeter. So this end is at 20 centimeter. The rod has got a length of 10 centimeter. So the other end must be at 30 centimeter. This is the picture. Concave mirror, focal length 10, radius of curvature 20, object lying on the principal axis, length 10 centimeter, closer end 20 centimeter. So the farthest end must be 20 plus 10, 30 centimeter. Now what you need to find? The length of the image. How to find the length of the image? Let us call this end as A and this end as B. A will have an image, B will have an image. Locate A and B. But if you are wise and if you are smart and if you are fast, then you will understand that this is center of curvature. So the image will be again at the center of curvature. So A will have its image at A dash at the same point. So I can draw the image here. So A dash will appear here itself. And where is B dash? B is at a distance 30 centimeters. So what I am going to do is that I am taking this distance B. So I will take U is equal to 30 centimeter with minus sign. Tell me why minus? Because object here, light is going to the right, you are measuring from pole to the left, so 30 is minus 30. And what about focal length? It's a concave mirror, focal length is minus 10 centimeter. We need to find out its image. So we use the equation V equals UF by U minus F. Therefore, V equal to, substitute value, what is U? U is minus 30 into what is F? Minus 10 divided by minus 30 minus minus 10. So minus into minus is plus, 30 into 10 divided by, I can write it as 300, but this is always easy. Simplify only at the last step. Okay, divide by minus 30 plus 10, minus 30 plus 10. So this gives you 30 into 10 divided by minus 10 plus minus 30 plus 10 minus 20. 0 cancel 0, minus 2 cancel 32, minus 15 centimeter. So where is the image of B? Image of B is at 15 centimeter from the pole in the negative direction. That means this B dash will appear here. This is B dash. अरे बच्चों सुनो, A has its image at A dash. Why? Because A is at center of curvature, its image will be again at the center of curvature. But B is away from the center of curvature, so its image must be between 2F and F. That's what we got as B dash. And the image will look like this. This is the image. This is the image. This is the object, this is the image. And the length of the object is given 10. What is the length of the image? See, one end is at 10, other end is at 15 from the mirror. So this distance is 15, this is 20. So what must be the length of the image? It must be 20 minus 15. So we can say length of the image must be equal to, take only the magnitude of that value, that is 20 minus 15, which should be equal to 5 centimeters. Okay, so we have our option 5 centimeter. Practice this because such questions are very rare. Okay, so this is object lying along the principal axis. This is for the attention of those who are aiming for JEE, IIT, KVPY, etc. Because in ray optics, normally vectors will not come. But the direction of ray of light can be expressed in the form of vectors. Many times in JEE, mains as well as advanced, they have used this method. In the NEET examination, so far they haven't done it. Okay, but I think we must be careful. There is a ray of light traveling in the direction half I plus root 3j. Which quadrant is this? This must be in the first quadrant. So there is a ray going like this. After reflection from a plane mirror, it travels along the direction half bracket I minus root 3j. So this must be the fourth quadrant. So this must be traveling like this. What is the angle of incidence? That's the question. What is the angle of incidence? Those who are good in mathematics can give the answer simply by looking at this. You can get the answer. Others will have to struggle a bit. Now, let us use common sense. A ray of light which is going like this will have to change to in this direction. So, where is the mirror? The mirror, see, this is the, suppose it is incident somewhere here and going like this one, this is how it goes. So, the mirror must be here. This is the mirror. That's one possibility. So, let us do like that. Let us do like that. I hope it's clear. Incident ray in the first quadrant. Those who are not so good in mathematics, please see, this is first quadrant. I x positive, y positive. This is the fourth quadrant, x positive but y negative. That's why fourth quadrant, first quadrant. Incident ray is like this one, reflected ray is like this one, means it has to go there and reflect. Like this, the mirror is here. Okay. Okay. Now what to do? Now what to do? Okay, let us take a whole board for doing this. Blue color. So I have my mirror in the horizontal plane. There is a light ray coming like this, then the light ray is going like this. This is the incident ray, reflected ray. Incident ray is given as a vector A. Reflected ray is given as a vector B. Where is angle of incidence? That's what they want. Okay, we know this is the normal, this angle is called angle of incidence, and this is angle of reflection, that is also equal to y. So the total angle here is equal to 2y. I know you studied the concept of direction, angle between two vectors. Angle between two vectors is the angle between their forward directions. Angle between two vectors is the angle between their forward direction. So this vector A has got a forward direction like this. This has got a forward direction. This is the angle between vectors, and that's what we call as the angle of deviation in reflection. We studied this angle of deviation. I need angle between A and B. And what is the angle between A and B equation? See this. Check whether this is familiar. Cos delta is equal to A dot B. I can see smiles on your face, by magnitude of A and B. Cos delta. If I know delta, I can find out I. Okay, let us do this. What is A? Vector A, I hope you remember, vector A was half times I plus root 3j dot, other one was, so this is the first vector, dot half times I minus root 3j divided by magnitude of the vector. Magnitude of the vector, you know, it's root of a square plus b square, so that is root of, okay, the first vector is 1 by 2 square plus second vector is root 3 by 2 square into magnitude of the second vector b is again same thing, it is half square plus root 3 by 2 square. So what will I get? Half I dot half I will give you 1 by 4. Similarly, root 3 by 2j dot minus root 3 by 2 will give you minus root 3 by 4. I'm sorry, minus 3 by 4. That will give you root 3 into root 3, that will give you 3 by 4 divided by half square is 1 by 4. This is 1 by 4 plus 3, root 3 by 2 square is 3 by 4 under the root into root of, again you will get 1 by 4 plus 3 by 4. Okay. 1 by 4 minus 3 by 4. 1 by 4 minus 3 by 4 gives you minus 1 by 2 divided by 1 by 4 plus 3 by 4 is 1. Root of 1 is 1 into same thing here 1. So the answer is minus 1 by 2. Okay. So what is the end of this? So we got cos delta equal to minus 1 by 2. So what is delta? Delta is equal to 120 degree. So this angle is 120 degree. So what is I? We know delta is equal to 180 minus 2i. Okay, 180 minus 2i. Therefore, 2i equal to 180 minus delta, which is 180 minus what we calculated, 120. Okay, so this gives you 60. 2i equal to 60, so I must be equal to 30 degree. So the angle of incidence is 30 degree. Okay, if you know vectors, you can do this very easily. I tell you how. Okay, so I am doing the easy part. So let me clear this. I clear this. See here, this was your mirror. Consider this as the y-axis, this as the x-axis. Your incident vector was coming like this. Okay, this vector can be extended up to this point. That is the direction, because direction is the same. So your extended vector is this. This is the normal. This is the angle of incidence, and this angle of incidence will appear here. This is the angle of incidence, and this vector is given by 1 by 2i minus root 3 by 2j. Sorry, this was given by 1 by 2i plus root 3 by 2j in the first quadrant. And this is the angle made by vector with the y-axis. And we know tan I equal to, this is not the vector, I think, not I cap, this is the angle of incidence I. Tan I is equal to the x component by the y component, vector x component by y component. And what is x component? That is half half divided by what is the y component, that is root 3 by 2. So this gives you 1 by root 3. So tan I is equal to 1 by root 3, which tells you that I is nothing but 30 degree. So the angle of incidence is 30 degree. So without going for the complicated vector multiplication, we can directly do this. Little common sense. This is again from apparent depth, but there are two liquids here. Okay, please read. There is a vessel. There is a vessel with water and oil, and the total depth of the vessel is half the depth of the vessel. Maybe it is completely filled with water and the oil. The total depth is x. So it is half filled with the water, and water will lie at the bottom, oil will stay at the top. This is oil, this is water. This has got a refractive index mu1, this has got a refractive index mu2. This is x by 2, this is also x by 2. They want apparent depth. So the total apparent depth, I'll write d apparent is equal to d apparent in the first liquid, this one, plus d apparent in the second liquid. You don't have to prove this. There is a proof for this, but it's beyond your scope. What is d apparent in the first one? We know apparent depth is nothing but real depth by refractive index. And what is the real depth in the first case? It is x by 2. You divide it by the refractive index mu1, plus second case x by 2 divided by mu2. Simplify this. Okay, so here we can see x by 2 is common, then you have 1 by mu1 plus 1 by mu2. Okay, so this gives you x by 2 into, this can be simplified as mu1 plus mu2 divided by mu1 mu2. So that gives you which option? That gives you x into mu1 plus mu2 divided by 2 mu1 mu2. So that will be your answer. Okay, so the total apparent depth is apparent depth in the first one, x by 2 mu1 plus x by 2 mu2. Take x by 2 common, then simplify. Okay, that's about 2k. If there are 3 layers also, you can do the same thing. Again from apparent depth, a different one. Air bubble in a glass slab. There is a glass slab. Consider a thick glass slab. There is a glass slab like this. Okay, and there is an air bubble. This is an air bubble. The glass slab has got a refractive index 1.5. Assume that this bubble is at a distance x from this side and at a distance y from this side. And we know the thickness of the glass slab will be equal to x plus y. That's what they want, the thickness. But air bubble is 5 centimeter deep when viewed from one side. When you view from this side, this will appear somewhere here at a distance 5. When you from this side, this will appear at a distance of 3 centimeter. Okay, this is apparent depth, this is actual depth. So what is actual depth x? X is nothing but, we know the equation, d apparent is equal to d real divided by refractive index. So d real is nothing but refractive index into apparent depth. Okay, so the real depth x is nothing but 5 into 1.5, 5 into 1.5 plus y will be equal to 3 into 1.5. This gives you 5 plus 3, 8 into 1.5, and that must be equal to 8 plus 4, 12 centimeter. So apparent depth will become 12 centimeter. This concept has come for board examination as well as entrance examination. This is about the total internal reflection, and for total internal reflection we should know the basic idea that total internal reflection is possible only when angle of incidence is greater than the critical angle, or you can even write instead of writing IC, you can write I greater than C, where C is the critical angle. This is a condition for total internal reflection. And what is given? A light ray incident perpendicularly to one face of a 90-degree prism and is totally internally reflected at glass air interface. If angle of reflection is 45 degree, we conclude that the refractive index of the material is, what is it? You have a prism, a light ray is incident normally, and you know that here normal incidence will go straight, and at this point it is going from glass to air, denser to rarer. First condition for TIR satisfied. Now if I is greater than C, total internal reflection will take place, but it is given that it is reflecting totally internally. So that condition, both the conditions are satisfied. Okay, both conditions are satisfied. So we want the refractive index. How to connect refractive index into this one? We know total internal reflection is possible only when I is greater than C. And what is I here? You can see from the diagram, this is I given as 45 degree. Angle of reflection is also 45 degree. So this is 45 degree and this should be greater than the critical angle. Let us apply sine on both the sides. Sine 45 degree greater than sine C. Take a reciprocal. Why? 1 by sine 45 degree. Those who know mathematics, this will be easy. Others, please listen. When you take a reciprocal, this sign will also reverse. This will reverse like this. Greater than will become less than 1 by sine C. What is 1 by sine 45 degree? Sine 45 is 1 by root 2. So that is 1 divided by 1 by root 2 should be less than 1 by sine C. And this is nothing but root 2 must be less than, what is 1 by sine C? Sine C is equal to 1 by n, therefore 1 by sine C should be equal to n. So this side should be equal to n. So what is the condition? Therefore, for this to happen, refractive index of the material must be greater than root 2. So n should be greater than root 2. So that is your answer. N must be greater than root 2. We will be doing more questions about lenses and all after a few more theory classes, but since we have done Lensmaker's equation, I will do one question on Lensmaker's equation. And what was Lensmaker's equation? It is an equation which gives you the focal length of a lens, and that was like 1 by f equal to n21 minus 1 into 1 by r1 minus 1 by r2 with the Cartesian sign convention. Okay. What is given? A plano-convex lens is given. A plano-convex lens, plano then convex. A plano-convex lens is given. Its refractive index is 1.6. Its refractive index is 1.6. The surrounding medium is not given. So when it is not given, we will assume that surrounding medium is air with refractive index 1. What is the focal length of the lens? Okay. So we will apply focal length of the lens, but before that, Cartesian sign convention. Let us assume that light is incident on this surface. This is a positive direction. Okay. So the lens has got two surfaces. The first surface is where light incident first. This is the second surface. Okay. Now this can be further written as n2 by n1 minus 1 into 1 by r1 minus 1 by r2. See, when I finish the question, many of you will get confused. So be careful and watch. What is n2? n2 stands for the refractive index of the material of the lens. n2 for the lens. So n2 here is 1.6 divided by n1 is the surrounding medium, which is 1 minus 1 bracket. R1 is the radius of curvature of the first surface, and the first surface is a plane surface. For a plane surface, radius of curvature is infinity. Plane surface, it is infinity. So I will write 1 by infinity minus 1 by radius of curvature of the second surface is given. Radius of curvature of the curved surface is given as 60. So this R2 is given as 60. But there is a problem. Cartesian sign convention. This R2 is part of a sphere like this. Its center must be somewhere here. Light is incident from left to right. So that is positive direction. You are measuring that in the negative direction. So this R2 is minus 60. So this gives you minus 60. Okay. So first surface is plane. Radius is infinity. Second surface has a radius 60, but it is negative. Substitute that here. So this gives you 1.6 by 1 minus 1 is nothing but 0.6 into 1 by infinity. Negligibly small, so take it as 0. Minus of minus plus will give you 1 by 60. This is 1 by f. Okay. I will finish it off here. Take the reciprocal. 1 by f is the reciprocal of 0.6 by 60, which is equal to 60 divided by 0.6, and 60 is in centimeter. 60 is in centimeter. So 60 by 0.6 will give you 100. That will be in centimeter. So your answer must be 100 centimeter. See here. Running? Okay. Sorry. See here. What I did is that I took a plano, then convex. Then I allowed light to fall on this surface. So many times students ask, what will happen? Even in an examination they ask it. Focal length when light falls from this side is f. What is the focal length when light falls from the other side? So we have done that in this way, and we got the answer as 100 centimeters. So what we are going to do is that we are going to change that side. We are going to change the side. Okay. I am taking the lens to be like this, and I am allowing light to fall in this direction. All other parameters will remain same. This is 1.6, refractive index 1. The surface has got a radius 60, and this is the plane surface. Its radius is infinity. Everything remains same, but light is incident on this side. What is the focal length? 1 by f is equal to, similarly, previous case 1.6 by 1 minus 1 times Which is the first surface? Where does light incident first? That is on the curved surface. Its radius is 60. And where is the center of that surface? That center will be here. So you will be measuring it from the pole to the center. So that is taken as plus 60. So this is R1 is plus 60 minus 1 by. It's an plane surface. Whether you measure it as minus infinity or plus infinity doesn't make any difference. So I reverse the light. Light is incident now on the convex side, and this is what I write. Hope it's clear. So this gives me 0.6 into 1 by 60. So F equal to 60 centimeter by 0.6 will give you 100 centimeter. So whether light falls on the convex side or the plane side, the behavior of the lens is the same. It will always focus light to 100 centimeter if the rays are coming parallel to the principal axis. That means if you have plane side or here and light falls on it like this, it will focus at 60, and if you keep it like this, allow light to fall, still it will focus to 60. The behavior will remain the same. More questions in the next session after completing the theory part.